Okay, class. So today we're going to have sort of a lot of information, but the key here is that the technology will do it all for you. So it's going to be kind of important that you follow along. I wish I could give you something that had a bunch of different screens so you didn't have to have other things open. It's kind of tricky for me to even do on one screen, but we're going to try and do the best we can. The more you practice with it, the easier it is to sort of do the steps. I'm never going to have you have to have it memorized and know how to do those steps on your own. So don't worry about that or anything in that regard. So first thing we need to remember is from our notes on either Monday or Tuesday, depending on whether you're green or gold, we talked about the correlation coefficient, right? And we said on that day that the correlation coefficient, so you should already have this in your notes, that the correlation coefficient has to be in between -1 and +1. Okay, that correlation coefficient is a big old fancy formula. And we can't do it by hand. We need technology to do it for us. But that correlation coefficient tells us how strongly the two pieces of information relate to each other. Okay, so if we've looked at the data, we've evaluated it, we deemed that there's a good correlation there. It's not just something mathematically ridiculous. Okay, we might then calculate the correlation coefficient to see just how strong it is. The closer we are when we calculate the correlation coefficient to +1, the stronger the relationship is. Okay, so this would be a strong positive. I guess I shouldn't say stronger. A strong positive relation. The closer we are to -1, we will have a strong negative correlation. Okay, the closer we are to 0 will be that there's no correlation. Okay, and if we're maybe at like 0.5, that would sort of be like a weak positive. -0.5 would be like a weak negative. Okay, and the closer it is, or the stronger the correlation is, the closer it is going to be to a line. So if we take a bunch of data points and we plot them on the coordinate plane, okay, and we get points that look like a perfect uphill line. Okay, that is a positive slope. It's basically a perfect line. This is going to be a very strong positive correlation. Okay, whereas if we graph something and we have it going this way, right, that's going to be a very strong negative correlation. Now, the more the points start to vary from our straight line, the weaker the correlation is. Okay, so this is still going downhill, but not sort of in that perfect line. And then if we start to get stuff going everywhere, well, now we've got no, okay, those are terrible points, but now we've got no correlation going on at all. Okay, so we're going to get our computer to sort of plot this data for us, see if it looks like a strong correlation, decide what that correlation is, okay, calculate that correlation coefficient, and then maybe even use it to predict some future values from it, right? Because our whole point of data is how can we then use it to make educated decisions? Okay, so I then have some info here. So I had linked on Canvas a link to Desmos, which is this graphing calculator. And I also had a link to some data sets. So that's what I have open up here are those data sets as well as the Desmos graphing calculator. Okay, and what I'm going to do in this graphing calculator, oops, I already have this open, you wouldn't. Okay, so when you first go to desmos.com and you open up the link, you're just going to get to a page like this. You're going to click on the graphing calculator. Okay, and the first thing that we want to do is look at this data over here. So we have data that represents the cost of a VHS tape. So the year and then the price that it costs. So in 1990, it cost $12.48. As opposed to 2005, it was $10.98. Okay. If we look at this data, right, do we just sort of see as the years are going up, the price is going down? So hopefully in our brain, we're starting to think, okay, when one goes up and the other goes down, that's a negative. So maybe some type of negative correlation is going on. But let's see for sure. So we're going to click this add item button on our screen, and we're going to add a table. And we're going to have to enter all of this data into this table. So I think the easiest thing to do is to go down the X column. So enter 1990 and then hit equals. Enter 1992 and then hit equals. Now, it's going to start to predict for you. 1994 is good, but my next one is 1998. So I have to fix that one. I have 2000, and then I have 2005. Okay, now I'm going to do my dollars. So 1248, 1230, 1215. You kind of just have to make sure you're not making any mistakes when you enter it. You get all those values entered correctly. Now, I'm going to just sort of zoom over here. So I'm going to play around with my zoom. I'm going to have to get to a big number, and I start to see my dots over here. Okay, so you can either choose to sort of play around with it until you get your data points to show on your screen, right? I'm starting to see them. I'm just zooming in and out. Or you can also choose to do some work with changing your window. So to do that, you could go into your settings here and sort of decide, right? We need our X values to be in between like 1990. So I'm going to go a little bit lower. 1980 and maybe 2010. And I need my X values to be between my Y values to be between, let's see, like $10 and $13. It's sort of up to you either way, as long as you can find your data points. So this definitely looks like it is going downhill. So we have a negative correlation. And these look really close to a straight line. So this looks like a strong negative correlation. Okay, so what we are going to do is we are now going to calculate the correlation coefficient. So to do this, we're going to go into a new box, right? So this was 1. Now I'm going to go into 2. And I'm going to type Y. And instead of equals, I'm going to pull up my little keypad here, or use your key on your computer. And you want to get your little tilde thing. It's right here. Because it's not Y is exactly, but I'm going to do Y is about M X plus B. Oops, I'm putting this in the wrong spot. Silly me. Okay, so I want Y1. All I did was type a 1 next to the Y, and it just pops up. So I did Y1, and then I did my little tilde. MX plus B, except I put a little 1 next to the X2. When you type a 1, it just makes it little for you. Okay, and you'll notice that you get a bunch of numbers popping out here. The R value is what tells us our correlation coefficient. So right here, R is our correlation coefficient. So R is negative 0.9964. That is really stinking close to negative 1. So this would be a very strong negative correlation, which we could tell because we saw a straight line. Now, what if we wanted to make future predictions? Like, how about the cost of a VHS tape in 2008? I don't have my data in that list, but let's see if I could find it. To do that, we are going to write the equation of this line that it generated. Okay, it's saying this line over here is the best it can do to sort of approximate those data points. Good news is you don't have to come up with that line. It tells you what it is right here for your M and for your B. So instead of we normally would say Y equals MX plus B. But if we know that M is this and we know that B is this, we can just plug those into our equation. So negative 0.100096 plus 211 0.711. And you'll notice that our line should fall right on top of it, which it does. Perfect. That means it's the exact same line. And while I'm still in this box, I'm going to go up to this wheel and I'm going to see some things pop up next to my equation, and I'm just going to hit table. Okay, and now it's turned my equation into a table. So if I want to calculate the year 2008, I'm just going to type it in, and it's going to tell me $10.71. If I want to calculate the year 2020, it's going to tell me $9.51. Now let's talk about if that seems reasonable. Does $9.51 seem reasonable for a VHS tape in the year 2020? And hopefully we say absolutely not, because VHS went extinct, basically. I hope you guys know what a VHS tape is, right? It plays a movie in a different type of player, right? We now have CDs, DVDs, other ways we stream, right? Things that did not exist, and it has just killed off the cost of a VHS tape. So while it might have done a good job of predicting the cost of a VHS tape at these years, it definitely doesn't do a good job of predicting a VHS tape now that that data is gone, right? Because they don't exist. Okay. So let's look at another one here. So I'm just going to delete this out by hitting X and get rid of it all. Now that we sort of know what we're doing, this represents the dollar amount of ice cream that was sold in a 6-day time frame. So the first thing I'm going to do is I'm going to press add, and then I'm going to do my table. I'm going to start entering my data. I guess I want to go down 2, 3, 4, 5. Okay, and I'm going to do my Y side. Okay. Now I'm going to find my data points on here, either again by zooming around or just changing my window. So I need my X value to be sort of between 0 and 10. 0 to 10. And I need my Y value to be between what? About, what do we got? 100. So maybe I'll go a little bit lower than that. What's my highest number? 350. So maybe I'll do 375. I don't know. I'm just kind of giving myself a window there. Okay, and so here are all my data points. That doesn't look very promising, right? We got data everywhere. So what would you predict that our correlation coefficient is going to be? Okay, so now hopefully we said that it's going to be somewhere close to no correlation. Okay, so now let's actually get our computer to predict it for us. So as a reminder, we're going to have to do Y1. Okay, and then we're going to do the little tilde, MX1 plus B. So I want you to tell me what you get for your correlation coefficient. Oops, I accidentally deleted it. Let me type it back in before I verify for you guys. When we look at this, our R value is negative 0.0469. That is nowhere near, -1 or 1, right? That's very close to 0. So no correlation, which is what we expected to happen. So if we see this best fit line it drew, right, this is going to be kind of silly to make future predictions off of, because does it matter what day in the week it is as to how much ice cream we sold? Well, no. So here it's kind of pointless to make future predictions because our data isn't worthwhile to do that. The correlation coefficient is close to 0. Our data isn't going to be useful to make future predictions. So let's look at one more. Now we have some data with height to weight. So let's get our data entered in. I'm just going through and typing in all my data. And then we're going to do the same thing down the other column. Okay, we're going to sort of find where our data's at. So I know I'm not going to see it over here because I'm not far enough over. right? You can change your windows or just zoom around until you find it. So here's my data. Now, this data looks a little bit more hopeful, but it definitely doesn't look like a straight line, right? See how I have this trend of it's kind of going uphill? So my prediction here is that my correlation coefficient is going to be somewhat positive. So I want you to tell me what your correlation coefficient is. So when you calculated this, you should have typed in y1, the tilde, mx1 plus b, and it tells us that r equals 0.6096, right? So we're not at a strong positive one, but we're definitely past 0.5. So we do have a relatively medium here, right? Correlation. Okay, so if we use this to make some future predictions, let's write the equation of the line, right? This isn't going to be great to predict your weight versus your height, but we could try. So if we say y equals our m is 5.06914 x plus negative 179.237. Our line falls on top of it, and we are going to turn this. Oops, do that. We are going to hit this once I'm in here. We are going to turn this into a table. And I want you to predict someone's weight if they are 68 inches tall. Okay, so we should have typed in 68, and we get approximately a weight of 165 pounds. Okay, I want you to approximate the weight if someone is 78 inches tall. We should have got 216. Okay, so again, these aren't precise. These are just educated based on the data that we have. Okay, so this is just a tool and a resource that we can use mathematically to look at statistics, to see what type of relationships things have, and then make predictions for future values.